Welcome to Weather Extra on CBSN Bay Area. I'm KPIX meteorologist Paul Hagan. Every week, we're taking a closer look at a weather topic, a deeper dive than what we can do within our daily weathercasts on KPIX. This week, we're taking a look at the impact of climate change on a big part of the Bay Area's economy, wine production. The future of fine wine production is likely to shift due to climate change because among agricultural products, wine grapes are one of the most sensitive crops to variations in temperature and precipitation, and the impact of climate change can affect the taste and quality of wine at almost every step of the winemaking process. Temperature and moisture are among the primary elements that affect the taste and quality of grapes, with growing season temperature being especially important in determining what areas are suitable for growing high-quality wine grapes. Warm climate wine regions generally have more consistent temperatures. A more gentle transition from summer to fall allows the grapes to ripen longer, but at the same time, it allows more of the natural acidity to be lost, which is a negative. This produces wines that have more fruity flavors and less acidity. Cool wine climate regions experience a steeper temperature gradient between summer and fall. Lower temperatures preserve the acidity, but the grapes take longer to ripen, producing more tart and acidic flavors. With climate change, some iconic regions may become too warm and or too dry for certain varieties of grapes. In the United States, the average growing season temperature from April through October has warmed up by an average of 2 degrees Fahrenheit since 1970. Over that same time, the growing season temperature has risen by 2.9 degrees Fahrenheit in California, and our state accounts for 85% of wine production in the U.S. and 12% of global wine production. For the highest quality wines, 3 conditions have to be met: warm temperatures, a low risk of frost damage, and no extreme heat. A warm growing season often means a good vintage, but long-term warming trends could mean that vineyards currently producing a high-quality Chardonnay may have to change to growing Merlot grapes in the future. Grapes for lower quality wine, often called table wine or jug wine, can be grown across nearly all climate ranges, but premium wine grapes can only be grown in places that support a delicate balance. Globally, wine grapes are grown in areas where the average growing season temperature, spring through fall, occurs within a narrow range of 18 degrees Fahrenheit. For some grapes, such as Pinot Noir, the average temperature range is a much narrower 3.6 degrees Fahrenheit. According to wine experts, even a 1 degree temperature change outside of that range can make the difference between a poor, good, or excellent vintage. Research has found that extreme heat in the growing season due to climate change could reduce areas that are currently capable of producing premium grapes by 50%. And another study found that areas suitable for viticulture globally will decrease by anywhere from 19% to 62% in major wine-producing regions by 2050 under the most likely climate change scenarios. We're seeing northward shifts in planting zones all across North America, and warming temperatures may force winemakers to move to cooler growing climates, whether at higher elevations or further north in the U.S. and Europe, or further south in South America, Australia, and New Zealand. You can see how much those growing zones have shifted over the past several decades. There are also potential water and land conservation impacts. Wine producers may have to increase irrigation or try to cool grapes through misting or sprinkling, and vineyards are moving into places like the Greater Yellowstone ecosystem and Tasmania, causing new conservation challenges. But it's not just temperatures, because nothing pairs well with wildfire smoke. Devastating wildfires have swept through a number of major wine-producing regions in recent years. Of course, the wine country fires here in California, but also Oregon, Greece, Australia, and Spain. Higher temperatures, drier conditions, increased fuel availability, and longer warm seasons, all linked to climate change, are increasing the wildfire risk. Fires can ravage vineyards and destroy winemaking equipment and tasting rooms, but even fires at a safe distance from a vineyard pose a threat to wine grapes. Smoke exposure occurs when grapes are exposed to wildfire smoke while ripening, potentially creating an unwanted, smoky, ashy taste and aroma. The threats to the wine industry don't stop there. Warmer temperatures are projected to increase the likelihood of grape insect pests. Warmer temperatures allow many insect species to live longer and range further, while shorter, milder winters may not kill off harmful fungi or other pests. Vineyards are also vulnerable to the same severe weather events that can destroy other types of crops: early frosts, hail, heat waves. We hear that in the Bay Area a lot. Heavier precipitation and flooding, and drought, also something we're focused on around the Bay Area. Extreme weather events have become more frequent and more intense as a result of human-induced climate change. Now, none of that means that the California wine industry is in immediate jeopardy, or that operations are suddenly going to pack up and move north to British Columbia. But it does mean that the challenges vintners have faced over the past several years, drought, fires, extreme temperatures, are going to be recurring challenges for local production for the industry as a whole. One bit of good news is that when climate change impacts the grapes in the vineyards, there are options within the winery. Winemakers can add color, acid, sugar, and other flavors through the addition of blends of other wine grapes. That's it for this week's Weather Extra. Meteorologist Darren Peck will be back with another topic next week, and we are inviting you to play a role. If you have a weather or climate question, you can just email it to us, weatherextra@kpix.cbs.com.